Hello, my name is Benhard Flaxon Masebo. I'm a senior mathematics teacher holding bachelor degree of mathematics. Today I'm going to share with you the part of mathematics in particular to advanced level, that is from 5, specifically the topic of algebra. As we have been going on with our part of algebra, we touched the introduction part of algebra and the concept of exponent, and then we went very far to touch the idea of logarithms, and then we covered the part of series, that is for the part of arithmetic progression, geometrical progression, and other series. And then from that part of other series, I was talking about the idea of standard series. That was concerning with the part of the sum of natural numbers, the sum of the square of natural numbers, the sum of cube of natural numbers. And we touched some good questions, and the most promising one, how one can challenge you with some typical questions relating with that part. And then we went very far with the part of the concept of partial fraction, breaking the relational function into parts called the partial fraction, and the process was called the partialization. So today, I'm going to give you one briefing question involving the part of partial fractions, and then we'll be switching for the next part of our topic of algebra. This one is to check the question where one can say partializing, one can give us partialize 2 over x power 3 plus 1. This counter example of a question is looking like strictly different and difficult from the general knowledge of partial fraction. You know why? One could say, with all forms of partial fractions, we touch the partial fractions which is in the part of linear factors for the denominator, and also we touch the partial fractions which is in the part of quadratic factors, and we talked about repeated factors and improper fractions. So upon looking to this question, it seems as different that it is not switching to any kind of the forms of partial fractions which we covered, because you can see is a polynomial of degree 3. So to treat this question, proceed like this. We say solution, we say to treat this question, proceed as below. First of all, try to think the best expansion which can be giving you x power 3 as well as plus 1. This is simply as coming from x plus 1 power 3. Expanding this is giving us x power 3 plus 3x squared plus 3x plus 1. Now we are in the position where we can be transposing x power 3 and 1. These ones are x power 3 and 1. They are the part of the question which is given here. Therefore, one could be just taking the other side for the term of 3x squared and 3x, bring it to the next other side of an equal sign. It will be changing to become minus. So we have x plus 1 power 3 minus 3x squared minus 3x, and this side x power 3 plus 1, which is a part of the concern of our expression in our question. Therefore, performing simple factorization with this part here, it is simply giving us 3x, bring outside, so one has x plus 1 here, and in this one, x plus 1 power 3, with the other side, x power 3 plus 1. Upon checking these ones, there exists common factor, that is to say x plus 1. So therefore, factoring out the common factor from the two terms here, it appears as x plus 1, and the factoring out x plus 1 square minus 3, x capital bracketing here, and x power 3 plus 1. What does this signify? It simply signifies that upon expanding this perfect square, simplifying and then subtracting 3x, it just gives us x squared plus 2, x plus 1 minus 3x. In the same way here, outside of the brackets, and then it gives x power 3 plus 1. We are now able to operate algebraically this part, which is simply now x plus 1, and here x squared minus x plus 1 equals to x power 3 plus 1. So it signifies that 2 over x power 3 plus 1 is equivalent to 2 over, this time now we simply have x plus 1, and in that order, brackets x squared, or we say minus x plus 1. We are now able to perform partialization from this part, which now it is easily now performing a denominator with linear factor and quadratic. So partialization here, it will be appearing as 2 over x plus 1 and x squared minus x plus 1 equals to a over x plus 1, it is a linear factor denominator, and then plus bx plus c over x squared minus x plus 1, which is a quadratic now. And then upon avoiding denominator, multiplying both sides for this denominator here, it gives us 2 equals to a with the x squared minus the x plus 1, and here with the bx plus c bracketing here, again, which again gives us x plus 1, which is now easy to expand the class. Upon expanding here, one is just trying to correct like terms together, terms which taking the coefficient of x squared, it will be taking this a x squared, and when bx and this one, so you have a plus b, they all contain x squared. And then terms containing x, which is a coefficient of x, we will be having negative a here, and also here bx times 1 and c times x. Therefore, we are going to have b times 1, c times x, and again negative a, brackets here, they all take square, and we will also go furthermore, coefficients of, we say constant terms. Constant terms here is only a plus c plus c. And the next side here, it takes 0x squared, again 0x plus 2. What do we do now here? We will be comparing coefficients. The coefficients of x squared, a plus b equals to 0, and again we come to this part here, b plus c minus a equals to 0, and a plus c equals to 2. What does it signify? It means a equals to negative c. We are now able to replace wherever there is c by, wherever there is c, by a. Or we can simply say what is this? This was supposed to be 2, please. A means what? 2 minus c. That is what we mean here. So it means we can just come in our A, or we can make our C the subject, becoming 2 minus A. Therefore, we just come from this equation, which is taking b plus c. In the place value of c, it replaced by 2 minus a, with minus a also here, and equal side 0. Arranging this one mathematically is negative 2a plus b equals to negative 2. We are now able to solve the two equations. We say these two simultaneously, treating this one by elimination methods. We simply take this one. It is the same as to write what? A plus b equals to 0. And again, another equation, negative 2a plus b is also the same as negative 2. So elimination method, treat minus sign here, which is now is giving us positive 3a, and here is giving positive 2. What is a now? It means our a is 2 over 3. When a is given, it is definitely c is given again. Our c will become 2 minus a, where a is 2 over 3. Performing here operation, putting supportive number and finding LCM, 3, and here 6 minus 2, which is 4 now. So our c becomes 4 over 3. In the same way, our b now, b equals to negative a. And since a is known as 2 over 3, it signifies that b equals to negative 2 over 3. So partialization means what? Replacing these ones and taking the original question. So we say 2 over x power 3 plus 1 is the same as now a, where a is known, is 2 over 3 x plus 1 plus b. Our b is negative 2 x with c again is 4. They all contain denominator 3, so I can just put 3 here down and then putting x squared minus x plus 1, hence partialized. You can see, student, how this question is very impressive, too good. And then you'll be using the same trick. I can say try this. Try this. 3 over x power 3 minus 1. Partialize this. Try this in partial fractions. Partial fraction. Expressing this in partial fraction. Okay. Thank you very much. Now we are going to move with another part of algebra, at least after briefing this one. And I hope now you have really enjoyed enough. Thank you. Okay, student, let us now check the concept of telescopic series. Sometimes we simply say summation of series by partial fraction. Summation of series by partial fraction. Most times other mathematicians, they used it to call it as telescopic series. Using the knowledge of partial fraction, I will be taking you step by step with the idea of telescopic series, and to find their sum, you will see it is just the application of partial fraction. So we say, summation of series by partial fraction. Partial fraction. These are series which exist in the form of partial fractions. How do we make them to find the sum? We say, we simply partialize the series, hence find their sum by partializing. we simply find the sum of series by partial fraction simply by partializing. So here we say we simply partialize the series, hence find their sum by partializing and cancellation. There is a cancellation rule which always works to find the sum. So let us check some worked examples. Okay, checking these questions which we have posed here, these two ones, one is a sum up to any terms and another is the sum to infinity. Sum to infinity. How do we find the sum of these series? We simply first need to partialize. As I have written here, we simply partialize the series, hence find their sum by partializing and cancellation. So solution here, solution. How do we treat this? We do like this. Taking these ones, we say, the partial fraction here in this series is simply is equals to, we'll be taking a over n, b over n plus 1, c over n plus 2, performing partial fraction, multiplying this one both sides. It will be giving us 1 equals to a times n plus 1, n plus 2, plus b, n plus 2, and here we have c, n plus 1. So here we say, when n equals to 0, when n equals to 0, this one cancels, and this one cancels, so remains here 1 equals to a 1 times 2, therefore a becomes 1 over 2. When n equals to negative 1, this will be cancelling, and this term is cancelling. We only have this, therefore 1 equals to b times negative 1 times 1, therefore our b becomes negative 1. When n equals to negative 2, therefore this term cancels and this one cancels. We only have this part here, which now becomes c as it means we want to deduce for c, therefore we have c, therefore negative 2 and negative 1, which means our c gives what? A half. So we are now done with partialization. It means this one becomes c equals to our a 1 over 2 n minus our b negative 1 n plus 1, and here our c 1 over 2 n plus 2 here bracketing. So we say the sum is. To find the sum now, we will just, instead of finding the sum just summing this one mechanically from the first term, performing this mechanically, sometimes we call it performing it manually, adding these ones, the first term, adding the second one, going up to this one is critical and wastage of time. And therefore, one will just make the concept, call it what? Finding their sum by partializing and cancellation. How do we make it? It means we proceed like this. We just bring this. We say, when n is 1, in this part here, it means the sum, it will be remaining 1 over 2 minus 1 over 2. It means we plugging 1 here, 2 times 1. And here plugging 1 here, so 3 times 2, 6. So 1 over 6. When n is 2, therefore this one giving us 1 over 4 minus 1 over 2 plus, so when it's 2 now, that is when you say 2 plus 2, 4 and times 2, that is 8, 1 over 8. When n is 3, this one is giving 1 over 6 minus 1 over 4, and again here, when is 3, 3 which is 5 times 2, 10, okay, that is 10 here class. When you check the trend for the series, you will notice that upon summing this one again, summing this one again, keep on summing, you will find that algebraically, this 1 over 6 and 1 over 6, when you sum, is giving us 2 over 6. Simplification of this is giving us what? Simplification of this is giving us is 1 over 3. So we continue again. When n is 4, this is going to give us 1 over 8. 1 over 8. 1 over 8. When n is 4, 1 over 8 minus when is 4, 1 over 5 plus when n is 4, that is 6, 12. 1 over 12. Again, keep on summing this column-wise. So we want to check this, the cancellation, how it can work. Summing this one, you will find 1 over 8 and 1 over 8. When we sum, is 2 over 8. Cancellation, and this 1 over 4, it means 1 over 8. 1 over 8, that is 2 over 8. Cancellation, 1 over 4. Is cancelled with this negative. So this diagonal is cancelling. Of course, this one was a mathematical problem. It is supposed to give 3 here. This was 3. True. This is the 3. So with this 3 here, 1 over 6. 1 over 6. That is 2 over 6. Cancel it. Simplifying. That is 1 over 3. Is cancelling diagonally with this one. So terms will keep on cancelling diagonally. You will notice that we only have 2 terms in this party. So terms up to the end, when we will put n equals to the last term, n at the end, a certain number, n equals to n, term at the end. There are so many term numbers here, keeps on giving the result upon plugging the value of n. So when n equals to n minus 1, I mean the second term from the end, there down, putting to our formula. Second term from the end, which is n here. So when you put n minus 1, plugging, 2 goes inside, you will remain with the 1 over 2 n minus 2 minus n minus 1. I mean the second term from the end. This is going to give us 1 over n plus. Second term from the end, n minus 1. So becoming n plus 1, avoiding brackets, 1 over 2 n plus 2. So the last term, when n equals to n, I mean the last term from the bottom, I mean here, plugging here is 1 over 2 n minus 1 over n plus 1. It repeats the same series here. So 1 over 2 n plus what? Plus 4. We have noted that two terms at the first corner point here at the top, these terms are uncancelled. So these two terms are uncancelled. So the term which is here is cancelling diagonally with this here, cancellation, and terms also keeps on cancelling. All terms at the middle, they all cancelling in that diagonal order, where you will notice that the sum now, it is only these two terms with this a half here, and the three are the one uncancelled. So sum of n terms here now becoming easy to say 1 over 2, which is this a half, minus 1 over 2, which is this one, plus 1 over 4, which is this term here, this number here, and taking these ones, which is plus 1 over 2 n plus 2, plus 1 over 2 n plus 4, plus, this now becomes minus negative 1 over this one. So summing these ones cancels here. We have sum of n becoming 1 over 4. We could be finding LCM on this, which is simply this one 2 n plus 1 times what? Times another 2 n plus 2 n plus 1. LCM on this, bringing this to this part, it means we will be having some cancellation. It means this one is cancelling. You perform now, getting the sum, which is easy to conclude. You can see how it is interesting. We are now able to switch to the second example, that is B. Okay, let us check it. With B, using the same trick, one putting B here, we could be easily again finding the partial fraction of this term here. Finding the partial fraction of this term, it is simple to say, it is simple as 1 over n plus 1. The general formula of this series here. So partializing this is A over n, B over n plus 1, multiplying both sides, checking that. So you have 1 equals to A, n plus 1, and B, n. So when n is 0, I can just treat this directly. When n is 0, this vanishing, giving A equals to 1. When n is negative 1, giving B equals to negative 1. So partialization, 1 over n plus 1 gives us our A, which is 1 over n minus our B. Okay. We are now able to partialize, which is, we have already partialized it. We will simply now go to find the sum. Now let us check how the sum will work. Okay, let's switch on. Let's go together. Okay, let's look now our question. We have already partialized it. It was just from 1 over 1 times 2, 1 over 2 times 3, plus our partial fraction is n plus 1, which we have got A, partializing this one, partializing this is equivalently as 1 over n minus 1 over n plus 1. So we want to find the sum of the series. And our series was just taking sum to infinity. So to partialize this, we will simply say, when n is 1, it means we'll be having 1 over 1 minus 1 over 2. When n is 2, we have 1 over 2 minus 1 over 3. When n is 3, we have 1 over 3 minus 1 over 4. So keep on plugging value of n. Terms keeps on appearing, and it keeps on appearing. So here, checking in diagonal, these ones cancels. These ones cancels. These one. So terms cancels to infinity. They keep on cancelling to infinity. So the sum only becoming this. This is called sum to infinity. So giving only 1. which is only this term. So it keeps on summing, cancelling downward to infinity. Okay. Again, now let's look another question. Another question. One can give us a question like, verify that in 2x minus 1 square minus 2x plus 3 square, that is equivalent to, verify that is equivalent to negative 8 bracket 2x plus 1. Upon verifying, it says, hence, use the result to find the sum in sigma negative 80, and here we have 2r plus 1 and r from 1 to n. Verify that in 2x minus 1 bracket square minus 2x plus 3 bracket square is equivalent to negative 80 2x plus 1. And hence says, hence use the result. It means we know this is a result of this. So when one says, use the result to find the sum in this, we simply proceed like this. Solution. We want first to verify that this expression is just a result of this. So we say, recall a square minus b square is a minus b, again a plus b. This is called difference of two squares. We then come here with this 2x minus 1 square minus 2x plus 3 square. So to be taking 2x minus 1 minus 2x plus 3, capital brackets, times 2x minus 1 plus 2x plus 3. So avoiding brackets here, you'll find cancellation on this. So negative 4, and here 4x plus 2. Bring this 2 outside, negative 4 times 2, and here 2x plus 1, and negative 8, 2x plus 1. We say hence verified. Hence verified. After verifying that negative 80 brackets, open brackets 2x plus 1 is a result of this much here, which is this part. It means we say thus negative 80 sigma 2x plus 1, 2x plus 1 from 1 to n, x from 1 to n is equivalent to sigma 2x minus 1 square minus 2x plus 3 square. So we will be saying the same as x from 1 to n. So we make that proportional equivalence trick that this one is the same as writing. So what the question is asking to find the sum of this expression. Use the result to find the sum. This sum here, now we are using this part. We will be only treating such that the place value of x now being replaced by r. So we say, so to find the sum now, it will be simply like finding the sum here. It means we say when x equals to 1 in this part, which is proportionally with this one, so becoming plugging here, it will be giving us 1, because we just say 1 square minus when it is 1 again here, 1 is 5. 5 square. When x is 2, becoming 2, so becoming, that is 4 minus 1, 3 square minus z. Putting 2 here, so 4, and then is what? Is 7. 7 square. Again, when x is 3, this is giving what? 5 square minus z. And here, when it's 3, therefore with 3, that is 6 and 9. 9 square. When x is 4 again, we continue. This one is giving us 7 square minus z. That is, it was 7 when it's 4. So putting here 4. 4 means what? 8 plus 3, 11 square. So checking, we'll keep on plugging these numbers. If you look here, you'll find that this 5 cancels with this one diagonally, and this one diagonally, terms cancels. So it means there exist 2 terms and cancelled at the end. So at the beginning, first corner, at the beginning, we will be having 2 terms at the end corner in this juncture here. Therefore, these 2 terms at the end in that juncture will be giving us this one, which is what? Which is remaining as 2n plus 1 square here minus 2n. Because here we say when n minus 1 at the end, n minus 1 at the end, terms remaining there at the end, n minus 3 at the end, n minus 3 square, term at the end, 2n minus 3 square minus term at the end, 2n minus 1 square. So the term which is here is strictly cancelling with this, and the other one cancels. So all terms in this part cancels. So remaining with this one here, only this. Therefore we say sum of n terms becoming 1 square plus 3 square minus z, which is this, 2n plus 1 square plus, keeps on summing, 2n plus 1 square, 2n plus 3, 2n plus 3 square, this one. So 1 performing this, which is 10 minus expanding this one, 4n square plus, this is 4n plus 1, plus 4n square, that is 6, so 12n plus 9 would be performing these ones, which is 80 n square plus, and with n here 16n, okay, and the 1 and that one, which is 10. Therefore the sum of n terms becoming negative 8n square, negative 16n, cancellation with 10, because this one negative will avoid that. So you could just bring it, you can bring it outside like negative 8n, so becoming what? n plus 2. This is the sum of n terms, which is easy to conclude. You can see this question is very interesting, and is a part which is concluding this part of the summation of the series, call it telescopic series. Now I will bring you to the other portions. Thank you. Thank you for watching. We are taking a short break. We will be right back. Don't go away.